Everybody, good to see all of you. So as I was introduced, I'm the product manager for Enterprise. It may be a little bizarre that the Enterprise product manager is giving a platform talk. Recently at Puppet, we've kind of reorganized our product engineering teams around particular themes. I'm responsible for the Enterprise, but one key important note, and this is a note that you're going to see some of the lessons learned in the Orchestrator project kind of led or contributed to the changes we're making internally. But one of them is that there's no teams focused on the open source software. There's no teams focused on the enterprise product exclusively. Instead, we have an area of focus. We have reasons for those focus. In the case of enterprise, it's what kind of customers are buying enterprise, what kind of needs they have that might differ from the open source deployments that many of you are running. But that doesn't mean that I don't work on contributing to the platform or enhancing its capabilities. And in large part, that's now a much more collaborative experience across all the product managers and engineering teams that we have. What I'm going to do today is give you a little bit of a primer on the direct Puppet workflow. You may have seen that at the keynote. Melinda Campbell's my UX lead for on our team. And she did a wonderful job giving you a glimpse of that workflow. And I'll give you a little bit more on how that works, and specifically how it'll work in the Puppet platform. Some of the pieces are there already that you can go home and try out tonight. Some are coming soon, and we'll talk about what those are. I had planned a demonstration of some of that workflow, but the internet's under siege. The White Walkers are coming, so I can't do that for you this afternoon, but I can always follow up and have that conversation with you, have a demo with you, or point you at things that are already out there for a more in-depth look. And with that, I'm going to start off with the elephant in the room. So for those of you that followed last year and saw my talk on the Orchestrator and specifically the application management language features that went along with our delivery of the Orchestrator in 2015.3, Puppet Enterprise 2015.3, you may have remembered that it's a commercial-only product. And it remains that today. But in a lot of ways, that was about our decision to try the commercial platform first. And I'll talk about that in a minute. But I wanted to just get out of the way that when it comes to direct change, that workflow for telling all of your agents, whatever agents they are, I want to check in now, I want real-time response, I want to be able to interactively control the agents that are running, where they're running, when they're running, be able to abort if things are going wrong. That's a core capability for us. That's just part of the platform. We have some tooling gaps to fill in, but we're closing those. And we're a little bit late to the party, mea culpa on that, but that doesn't change the intent that it is a fundamental platform feature. So as you see me describe this today, I'll primarily be talking about the enterprise workflow you can use with Puppet Enterprise today, especially with the product we shipped yesterday. But the core workflow is coming to you in tooling from Puppet, and you're able to use it today with other tooling that's available in the community, and I'll talk about that as well. So the primary reason that it's commercial first is because Luke Knies is Scrooge McDuck. It's true. But seriously, it wasn't a money grab. It's not that we went commercial first because we want your money. Well, we do want your money. I like to eat. I like to live in Portland, Oregon. It's a wonderful city. But we didn't choose to go into the commercial product for that reason. The Orchestrator for us was an experiment in what can we do with this Puppet Enterprise platform that we built up over the years. Because it makes a lot of assumptions that you don't necessarily make in your open source deployments. For instance, it needs PuppetDB. PuppetDB is the core engine by which information is exchanged, by which we store information about how deployments went. We retrieve report data from that in real time. So that whole feedback loop that I'm going to describe for you in more detail depends on PuppetDB being there with particular feature set. It also depends on a new compiler that I'll be talking about. It depends on agents operating in a certain way, being configured to operate off their cache catalogs. It relies on a new that coordinates the activities of all the Puppet agents. And it relies on a new addition to the Puppet language. So when you take all of those components combined, we thought, why not try building on top of the enterprise platform, ship this idea, see how well that goes, iterate on it, and then bring it to the platform. That was always the intent, and I hope that I expressed that last year. But admittedly, it's been a little bit longer than I had wished to get that feedback in place. And honestly, the reason for that is just a little bit of a blind spot on Puppet 4 adoption. How many of you are running Puppet 4 in production today? That's wonderful. I'm glad to see it. When we launched last year, I would imagine many of you weren't. And frankly, a lot of our customers weren't yet on Puppet 4. And further, the customers who are on Puppet Enterprise hadn't yet adopted the Puppet 4 version of Puppet Enterprise. And so that core idea of shipping this thing on the platform we can make assumptions with and learning how our customers like it, how they use it, and then bringing it to the platform, that wasn't as possible as we would have liked without the Puppet 4 adoption we needed. So you've seen Eric Sorensen, my peer on the ecosystem. He runs product for ecosystem. I hope some of you saw his platform talk yesterday. He's done an amazing job with the team at Puppet, making the upgrade experience to Puppet 4 easier, making our catalog preview tooling better and available to everyone, getting a lot of documentation and guidance out there, helping our module community adopt Puppet 4 patterns and starting to make some modules Puppet 4 only. You'll see the Puppet Labs NTP module is a reference module on how to do that well. All of those things have really pulled the line forward, and I hope that those of you who are on Puppet 4 enjoyed some of those resources, and those of you who aren't on Puppet 4 yet are able to use those to move forward. And an aside on that, just because I have time from the demo, if you think about that Puppet language shift, the way I like to think about it, and I think this is quite true, we started Puppet's language, Luke Knies wrote it essentially 10 years ago, and then he hired people to keep iterating on it, community members iterating on it. And so you got to the Puppet 3 series, and we had a really nice Puppet, especially the infrastructure around it. If you think about Factor, the Puppet server, and a lot of parts of Puppet's internals were really, really good. And we had gotten really good at making that software. But we had a language that was inconsistent in its behaviors. Some behaviors you might say you rely upon, while we might say, or you might say, that that's a bug. And we had no way to reconcile that distinction or that different perspective. And then there were other things about just what is the specification for this language? How do you parse it? How do you build catalogs? How can you start relying on certain language features so that you can expose a radio button in the console that resolves down to true false on a class parameter? None of that existed in the language. And so think of Puppet 4, the language anyway, as a true-up of looking at a company that had progressed 10 years, gone from a dozen employees, 60 when I joined 5 years ago, to a company of now 460 people. That kind of a shift gave us learning, a lot of new ideas, and certainly the experience we have all had working on that product together. And so Puppet 4 was as close as possible to a compatible language release that gave us a specification we can rely on, behaviors that are consistent, and a platform that we can build on for many years. So that upgrade to Puppet 4, talk to your peers here at the conference if you haven't already. It shouldn't be that big of a deal. We hear a lot from our customers that there is some work required. The tooling for catalog preview, for instance, will uncover your numbers should be actual integers instead of strings so that you can start to rely on them as integers. Things of that nature have shifted and will require some attention. Use that as an opportunity to refactor your code, or better yet, go to the Forge, which in the time since you deployed probably quadrupled in modules, and not just the quantity, but the quality and the number of contributors. So look at that Apache module you wrote in-house that you'd have to now move to Puppet 4 and think, why don't I just get a Puppet 4 compliant module from our community, supported or otherwise. So once you're there, and obviously there's no guarantees in software, but it's our expectation that any language additions from here on out are additions. There's going to be minor API incompatibilities. There's going to be for Puppet 5, for instance, at some point, but it's not going to be a language rewrite. It's not going to require you to go and refactor all of your content. You may have new features to add to the content, like the application constructs I'm going to talk about in a moment, but that's the idea. That's why we went to Puppet 4. Thanks for the aside. So application management, this is something we've talked about for a while now, but just as a refresher, this is fundamentally about teaching Puppet the relationships between your nodes. And you may not need this. You may be using it already. You may just be relying on consistency to get there. But the idea is you describe in a new application manifest, which behaves a lot like a defined resource type, that you declare components within it, database service, a web service, and load balancer in this example. And those logical services, think of those as your profiles. And in a lot of cases, they literally will be profile declarations. We design the application modeling to accept classes, defined resource types, native resource types as components. And the idea is you should be able to reuse stuff from the Forge, your existing profiles. You may build another wrapper for other reasons, but you plug those in. And then you exchange resources between them. We call these capability or environment level resources. And these examples, SQL and HTTP. If you're familiar with the platform, think of this as an exported resource that the orchestrator is managing for you. So you don't have to explicitly export it. You don't have to explicitly consume it. The orchestrator is doing that, but it's the same backend, and that's one of the reasons we rely on PuppetDB. But the idea is that you create a contract between those two components, or any components in your application. In the case of your database service and your web service, it's pretty logical. Where's the host? What port do I connect to? What are the credentials to connect to that database? The database name. And you may put in data there, or in properties in Puppet providers terms, that aren't functional, but are informative. What's the schema? What version of the database service am I running? Does it have all these extensions, like the Postgres extensions, for instance? And that's just a resource that we ship around. And that contract forms a barrier between these components. And one of the core aspects of this design is that you should be able to refactor any one of these services. You should be able to swap out a database layer, move from your own MySQL to Puppet Labs MySQL, and you shouldn't have to, after adopting the application modeling pattern, ever change how your web service speaks to that database service, because you're no longer hard coding your module to assume an interface on Puppet Labs MySQL. You're instead assuming a database resource that is more generic and abstract, and you can swap out Puppet implementations and move on with a different implementation of your Puppet code. The other side of that coin is the enforcement mode. I'm going to show you the difference between convergence and direct change in a moment. But the idea here is that with the orchestrator and the command line clients we're shipping, and again, these capabilities are coming to the platform to some degree, you run, for instance, a Puppet job that targets that application instance, or in the version we shipped yesterday, anything that you can express in the Puppet query language. So all of my machines in a particular data center running a particular fact or running a particular resource. And in real time, we reach out, run Puppet on those hosts, give you feedback on the resource events, changed, unchanged, no op, all of that, link you out to the Puppet Enterprise console for a detailed report, and then base decisions on how that run went. So if you have a dependency relationship between that web service and the database service, we ran Puppet on the database service. We're going to wait until the database service finishes running before we move on. And if that database service fails, we won't move on to configuring the web service against it. Those kind of qualities are what the orchestrator is handling. And it's based on a RESTful API. And of course, we're shipping a command line client with it. And that API has already been extended for, say, a HipChat plugin. We just shipped a Jenkins integration yesterday that uses the Orchestrator API. So you could have, for instance, a dev build pipeline where a developer pushes application code to a version control repository. That connects to a build pipeline, in the example, Jenkins. That will run your application tests, build the application package, and then make some calls to Puppet Enterprise. So update the version of the application that I just built and run the orchestrator to enforce that change. And the workflow in that case is that your developer pushes code to their development branch, and their changes are enforced live in real time as quickly as we can do it on the machines running that application code, so they don't have to run their own infrastructure. You don't have to be involved in every development deployment they do, but they're running their application on infrastructure that you're maintaining with all the baseline configurations, as representative to production as you can be. So I'm going to back up a second, because we're about to talk about that difference between convergence and direct Puppet. And I want to make sure we're all on the same page about how Puppet's configuration loop behaves. So this is the high level. You describe your infrastructure in Puppet code. That's no different if you described an application. And by the way, I didn't mention earlier, but that orchestrator, the run mode you're about to see, that is separate from applications. If you don't want to write the application modeling, if you don't have a need for those, you can still use the orchestrator to directly interact with your nodes, get real-time results, and target any pieces of your infrastructure. So in this case, you describe the model, and then Puppet, of course, allows you to simulate the difference between the existing state that Puppet found and the state you wanted it to be in. It can enforce that state and then report on the diff. That should be pretty clear for anyone using Puppet. But the key difference I want to make sure we're all aware of is the catalog bit. In case that isn't clear to you, we don't ship the Puppet code to the endpoint. When your agent runs, you're not getting everyone's code with everyone's manifest with all the credentials for all the environments. You get a compiled catalog, which is really just a text document of that machine's specific configuration at that point in time. That's called the catalog. The Puppet master compiles that, ships it to the node, It uses facts. Of course, first step is it gets facts, which are inputs to the catalog in addition to your code and your classification. You know all that. So that loop where the machine wakes up, gets a catalog, enforces it, sends a report. That's important for this conversation. So what I want to show you here is just a visual distinction, and I spent hours in Keynote making this animation. I did it a while ago, so don't thank me too much, but if you're not excited by it, I'm sorry. I invested a lot of time, wasted. The idea here is that you've got your build pipeline on the left. I'm abstracting all your module development. Maybe you've got a CI pipeline. Maybe you don't. Maybe you're pushing right to the Puppet master. But the idea in the convergence model is that everyone now is out of desired state. You've pushed some Puppet code. Let's say for this example, it applies to all of these machines. The idea now is that you wait. You saw Melinda kind of go ham on that yesterday. You kind of just sit there, wait, refresh your browser. Maybe you use mcollective or Ansible to run Puppet now because you don't want to wait. And the idea is, eventually, machines check in. And they may do that out of order. You may have shipped Puppet code right after half of your machines hit their run interval. Or if you're using Splay to distribute the load your Puppet master is getting, you may still have inconsistency. And then, if that AIX server fails, because it always will fail, you may not know about that for another half hour to an hour, or so on. That's the convergence model we live in today. I think we're all familiar with it. But just as a refresher, that's what it's like. So the key difference here, and sorry, this is PuppetConf 2014 branding. So sorry, Michael. We have our orchestrator. And the idea here is that it is sitting logically between your Puppet server and your agents. It's actually running as part of the Puppet Enterprise stack. And it would run as part of your Puppet server in the platform. But the idea is you put configuration. It goes through the same build and pipeline. Let's say you're using the Jenkins plugin we shipped yesterday. And then after that, you're pushing code to the Puppet server with our code manager. And then you make a call to the orchestrator. At that point, and we've already missed it, the machines immediately checked in and got their configurations. And now you may say, I want to run them in a particular order. The orchestrator can do that. It can run them in a particular order to match that web application that I showed you earlier. And then I might have two other machines that are unrelated run later. At that point, everybody, as quickly as possible, got the new configuration. And I have that little loop on the node because that doesn't mean that you sacrifice the remediation characteristics of Puppet. At the run interval, configurable still, 30 minutes is the default, as quickly as you want it, as long as you want it, that agent will still wake up, contact the Puppet server, and do its loop. So one key characteristic of this workflow is our cached catalog mode. That's been there for a while. We're just taking advantage of it. And when you flip that bit on, when the node wakes up, it doesn't request a new catalog. It instead uses the catalog it already had from the last time you used the orchestrator or you ran Puppet Agent-T or otherwise got a new catalog on that device. It then compares the existing state to the state in the catalog. It'll enforce or no-op, whatever you like, and send the report. And what that does for you is keep drift remediated while giving you an option to immediately enforce configurations on the machines as quickly as you want it. And it has the side benefit, or in my case, a primary benefit, of improving Puppet server performance. Because think about your Puppet server today. You've scaled that Puppet server up for your peak load. You're always running that thing to assume all of your infrastructure could converge at the same moment, and you need to be able to accommodate that load. That's fine in many cases. That's not a very beefy machine, but I know a lot of you are running a lot of Puppet servers to handle that peak load. The idea with the cache catalog mode, nobody's talking to the Puppet server. They're only retrieving files when they change. They're submitting facts and reports, which are pretty lightweight if there are things to report. Actually, it always sends the report, but it's still lightweight. And in that mode, when you're using the orchestrator to enforce change, the orchestrator is responsible for making sure your Puppet server doesn't go down. And it'll run as quickly as possible, as many compiles, as many Puppet runs as it can to get that change out as quickly as possible. So now your math changes from my Puppet server is as big as my peak load to my Puppet server is as big as I want change to occur, as quickly as I want it. So more CPUs, the faster I have, and you have a different calculus now. And you have a higher density should you wish to take advantage of it. And the other side of that, I use the API, but we have command line clients now. And yesterday, they shipped to your workstation. So on Windows, Mac, Linux, you can install command line clients for interacting with our RBAC service, get tokens to authenticate yourself to Puppet Enterprise, deploy Puppet code, and run orchestration jobs. In other words, run Puppet on your nodes. We also have a Puppet query tool that I don't have on the slide that allows you to interact with PuppetDB from your workstation. OK, now we're into the super professional images that I also labored on. And this is sort of the layout of the Puppet platform for orchestration and direct change. I'm going to go into these in a little bit of detail. But on the top left is sort of your code management platform. On the top right is that interaction between your agents and the Puppet server. And on the bottom right is a zoom in on the agent and the software it's running in it. Remember that in the Puppet 4 series, the Puppet agent itself has all the componentry necessary to interact with the Puppet stack. So it's got Puppet itself, the Puppet agent. It's got Factor, Hyra, mCollective agent, and the communications agent for the orchestrator. So let's zoom in on the code manager bit. On this side, and by the way, all these diagrams are sort of a mixture of Puppet Enterprise and PE, or sorry, in the open source platform. I'm trying to abstract them a little bit because it doesn't, or at least it won't soon matter which platform you're on for doing this workflow. But the idea here being you're still pushing to version control. Git in this example, but can be many things. And you're using Code Manager or R10K to deploy that Puppet code to your Puppet server. Code Manager gives you an API in Puppet Enterprise. R10K can be used to do that in conjunction with mCollective or many other community solutions that I'm sure you've deployed. And in Puppet Enterprise, we have this file sync service. The platform side, it's usually mCollective, which will distribute that content to all the Puppet servers. There's not a whole lot different going on there, but note that that is the intent, that you've got this workflow for pushing code, testing it, and getting it out to the Puppet servers. And that other side of the loop, once you have changes staged on your Puppet server, you need to run Puppet. So this is where we're talking about today the Orchestrator API. You can go and view the API on docs.puppet.com. There's an API index at the bottom of the site that has all of our APIs rolled up in the docs. But that Orchestrator API, you're going to see a subset of that move into the Puppet server so that you can trigger Puppet runs against anything Puppet query language can speak to, against applications, against environments. And you'll be able to ask, how's that Puppet run doing? What were the resource events from it? Is it done yet? Right, those kind of questions. The big difference between the commercial platform and the Puppet platform will be essentially state tracking. And the idea here, just follow me with this analogy. And I think if you've been following the Puppet community for a long time, this should be a natural progression of our thinking, but it may be a bit new than what you've learned. In general, we're trying to build Puppet Enterprise for distributed teams in large organizations and trying to identify what are those needs and what are those differences. Let's take RBAC, for instance. And I love the way Eric Sorensen teed this up in his platform talk yesterday. In that example, the RBAC service is only available in Puppet Enterprise. Because why do you need RBAC? Because you want to delegate certain permissions. You want to restrict who can touch what. Can somebody view reports and run Puppet but not push Puppet code? And that sort of suggests that you want to urge caution in interacting with your infrastructure because that infrastructure is precious to you. So it's worth money to you. So maybe some of that money can fuel the software that you're going to use to protect that infrastructure. Right? That seems like a pretty fair trade-off. The rest of it is on similar veins, not as discrete as the RBAC service. But in the case of the orchestrator, we have an RBAC integration so that you can authenticate and control who can run Puppet. And soon we'll make that more fine-grained so you can say who can run Puppet where. And then also track state over time. So you can ask questions of the API of last year, did somebody run Puppet on that host? Or what was the job that ran this morning that changed my machines? Who ran that? And you get some context of why they ran that by associating the git commit that they made before they initiated the orchestration job. And you also get things like, did an API user from Jenkins run this? Was it a human? Was it through the API? Was it the run Puppet button in the GUI? Was it a command line client? So you get a lot of context, and you get that tracked over time in the commercial product. In the platform, you get that same capability to run Puppet where you want it, when you want it, with real-time results. But we're not going to track that for you indefinitely. You're not going to be able to ask those detailed questions back over time. You're not going to be able to associate it with a human who did it with that context. That same idea of, if that's precious to you, there's money behind that preciousness. We'd like some, please? So on the agent side, I just want to call out that we have this execution protocol, and that's a new bit that was added in the Puppet agent when we shipped Puppet Enterprise 2015.3 and the associated Puppet version that has escaped my head. And the idea is that it is triggering the Puppet agent run. That's its only goal in life. It is not an M-collective replacement. It is not an ad hoc task execution engine. I'm sorry that if some of you were led to that conclusion, that's my bad. It's only there to run Puppet. The idea being M-collective is a very large animal for doing task orchestration. It's a good thing for that. But if you just want to run Puppet, it's a little heavy-handed. And we wanted something that had a much more tight feedback loop so that we can give you real-time results, that we can integrate with things like PuppetDB for getting report stream back. So we chose to build a protocol for that. Now, it itself is actually too heavy-handed, we learned. That was part of the learning of going into the commercial platform first. So part of what you're going to see, and why I can't ship it to you today, is that we're going to revise that communications product and make that lighter weight. So it's already C++ on the endpoint. So resource-wise, on the endpoint, it's really light already. And it's just sitting there waiting for someone to tell it to run Puppet, and all it does is run Puppet. But the server side is a little heavy-handed. We're going to make that lightweight, bring it into the Puppet server. Because of what I don't want for you in the platform to have to install new services, boot up new things to use this workflow. I want everyone in this room using direct change as quickly as possible. I think you're going to love it. I want to make that easy for you. So it should just be a new version of the Puppet server. You're going to need PuppetDB, though, so I hope you're already running it. It has so many other benefits. If you're not, it's going to be worth the effort. One other note, when the agent checks in and does its thing routinely, remember I said it has to be configured for that used cache catalog mode. Today, that's opt-in. At some point in the future, when all this tooling is available and all of you are so excited to be using this workflow, we're going to make that the default Puppet agent behavior. You'll probably still be able to disable it if there's a reason to do that, but it's going to be default in the future. You have to opt in today. And what the orchestrator does, or specifically this execution protocol, when it's told to run Puppet, it passes no used cache catalog, the inverse of used cache catalog. No magic. It's just saying, you go get an enforcement run now, instead of operate on the cache catalog. And that goes through the same Puppet loop that you experienced today. Sends facts, gets a catalog, enforces it, sends a report. OK. So now we're a bit into the plumbing on what you can do today. One of the things that you can do outside of direct change workflow, outside of application management, but it's there to facilitate both of those workflows, is static catalogs. If you don't use those workflows or you're not ready to do them yet, static catalogs can, if you're serving a lot of files from the Puppet server, remember like a file resource and the source is a Puppet URI, especially a Puppet URI from a module path, this will dramatically speed up the performance of your Puppet server. Because the idea here is that when an agent has to make a change to the file it's managing, it does a lot of chatter back to the Puppet server. It asks the Puppet server, hey, I've got this checksum. I need a new version of this checksum. What do you got? It does that all the time. It makes a lot of requests back and forth. We call these file metadata requests. And it does that because it's unsure of itself, and it's just very chatty. And then when it goes to get that file content from the Puppet server when it's changed on the endpoint, it goes and gets the latest that the Puppet server has on offer. Just whatever is on the file system gets served back to you. So the point of static catalogs is to solve both of those equations. Make less requests when it's unnecessary to make requests of the Puppet server. And when you do need to get a new file, go and get the file that was compiled at that point in time. Whenever I enforced last, I want that file back. In Puppet Enterprise, we have our file sync service, which does this automatically. It's essentially a Git reversion control repository that Puppet Enterprise manages so that every time you do a code deploy, we track a revision of, we know what the identifier was from your version control system, and we've got identifiers knowing that this catalog was derived from that set of inputs. And then when you go and request that file, we would go back in that history, grab that file, serve it to the Puppet agent. On the platform, you need to implement these two scripts, code ID command and code content command. These are endpoints like external facts or the external node classifier. It's very similar in a lot of the Puppet APIs in the platform. You run a script, you get some data as arguments to that script, and you're expected to provide output in a particular format. These are two reference scripts for a Git repository. These are on our doc site for static catalogs. The idea for code ID is that when you have a file, how do I identify it? What is the identifier for this piece of code, this file? So this script needs to return that, in this case, a git revision. And then we put that in the catalog. So we inline file metadata with every file resource that was served from the Puppet server with that code ID, so that when the agent requests it, it knows, I want this particular version of that file. The code content command is the script you run to retrieve that file from that identifier. So in this case, it's just grabbing out that file from Git, or the content anyway. OK, so that's data catalogs. I'm going to move on to this application management stuff in the platform. The idea here, the application manifest that you write, I feel is fairly good for a first rev anyway. It lets you compose applications. You can make those applications dynamic with Puppet 4's iteration syntax. You can say a web component can have 0, 1, 1 or more, so all kinds of permutations. You can expect specific data types to flow into your application using the type system in Puppet 4. So it's fairly complete in that sense. But one of the things it's pretty bad at right now is classifying application instances. We ship the bare bones version. Think of like when you go into your site manifest and you declare a class or you declare a resource that you want to apply to every node. It's that base level of classification for an application instance. But it means anytime you want to add a node to your web box, or like expand your web pool rather, you have to go and edit Puppet code to tell it, hey, I want to add this new web application server running on that host. You could commit that into version control, ship it to your Puppet server, and then you can add configuration for that node. Everything else is automatic. The load balancer will be automatically updated to point to that new web server. The database credentials will be automatically provided to the web server. Whatever those relationships are that you express in Puppet code, all of that's automatic, but the classification's static. So these examples here are to help with that. And they're sort of, for me and for Alex Dreyer, the engineer who wrote these, they're sort of a measure of giving you flexibility without asking you to do a whole lot more in your Puppet code. And we'll see whether or not we need to add proper language constructs, but I'm pretty happy with these functions. So this one is what you add whenever you want to make a tier of your application scalable, or in this case, when you want to pass in a scalable set of information into a load balancer. So there's a create component titles and a collect, or something like that. I think I have it on the next slide. But in this case, you just tell it this nodes hash, and that's kind of some, think of like in a defined resource type, you get $name for free. It's the instance name of that defined type. When you declare an application instance, you get nodes for free in addition to name. And nodes has all the mappings that you did. And so when we add classifier support for application instances, we'd get back all the instances you told us, all the nodes that are responsible for this web tier of this instance of the application. So that piece of data goes in first. Then you pass it the component, WordPress app LB. It doesn't have to be next to this spot in the file. That's why you specify it. And what it'll do then is automatically generate all the nodes that are associated with that application tier, and then it can be passed in to this load balancer like that with LB components. That just makes everything more flexible. It's a little heavy-handed explanation, but if you've used the application syntax, you know what I'm talking about. If you haven't used it yet, just go and use that function. Everything's better. This data capability type is a way to use some of the features of the application orchestrator without writing an application manifest, or at least all of it. In this case, you can say, I want to pass data between nodes. I don't want to go through exported resources, or I want that ordered exchange of information that the orchestrator provides. And you can just declare this type and declare which nodes it goes on, and that handles it for you. That dependency type, I think, is a little more useful. No information exchange, no availability checks. I just want to express a very simple relationship between nodes. Until the forge starts to be populated with a lot of those capability resources, you have to write them. They're custom types and providers. We have them out for HTTP and database or whatever. But if you don't need all the features they provide, this is a resource you can declare as your capability resource. And it's a lot like declaring a defined type. No Ruby code. Just declare it. Move on with your life. This is the one I was talking about earlier, create component app. This is the one where you can just pass into your site manifest here. And notice at the bottom, this is the first time I've showed you an application instance in DSL. The whole idea is you're passing data into it, again, like a defined resource type when you declare it. And that nodes hash is that free variable that you get in the model. And what you're doing is saying, I have these Puppet nodes, and they're associated with components of my application that I've defined in Puppet code. The difference, if you use that create component application as it's described in our docs, You can just say, yep, this node gets this array of these arbitrarily named things that I cared about, and then Puppet sorts out everything else. It sorts out, OK, I know what these are. I know how to transform the data so the load balancer gets what it needs and has all the data types. It's pretty handy. And again, this is app_modeling on the Forge. You can download it today. This one I think I'm most excited about for any of you who don't have a whole lot of complicated work that you want the application manager to do, the application language, I should say. But you do want node ordering so that when you use the orchestrator to do the direct change workflow, either in the Puppet server in the platform or with the orchestrator in Puppet Enterprise, you can use PQL to select any nodes you want, but maybe you have a few that you want to run in a particular order. Maybe you've already used exported resources to exchange information and you're happy with that, but you would like them to run in order instead of waiting on convergence. You can just declare this function in your site manifest. You declare the name of the ordering, and that's what you're going to tell Puppet. It creates like a fake application. So you would say, if you only wanted to work with those nodes, you could still have a title to pass. Or the orchestrator will just see them and run them in order if you use a PQL or Puppet query language. And you can pass, say, in the bottom example, where you have a 3-tier, you can say, I want to create databaseexample.com first. Then anything in that array, web 1, web 2, web 3, can all be run in parallel. And then there's more that's cut off of this slide that you would then express later. And in here, this is static, but you can call out to Hira for this data. You're not going to be able to use a whole lot of the hierarchy in data, or in Hira, because there is no sort of facts from a node in the environment level, in the environment scope. But you will have access to nodes. You can just ask for a key and get a hash of data back out from Hira. You can make a function call to ServiceNow or any other CMDB. You can make this dynamic and create some ordering for free just by dropping this in with some dynamic data lookup. That's my point. OK, I've been talking about Puppet query language a lot. I hope you saw it yesterday at the keynote. This, I think, is pretty great. I was going to show you a demo of this in a moment. That's OK. It's pretty awesome. Just try it. Anything PuppetDB can speak about, you can express both with the Puppet query tool to just get data out of PuppetDB. So show me all the nodes that have failed last. I want all their data. Or with the orchestrator, and the command line clients will ship in the Puppet platform to work against the Puppet server. You'll be able to say -- query. And in this case, nodes that are running the operating system of CentOS who are managing the HTTP resource, machines that checked in and failed last, machines in production, any combination of those things. It's pretty sweet. I'm pretty happy with it. This screen doesn't show you some of the grouping and paging constructs that Puppet query language has, which lets you make real phase deployments. So the first query can be, select all of my machines, but give me back 2 of them. Order them in a certain way, group them in a certain way. Then I want the next offset 2, or maybe that's 20, 200, whatever your canary size is. I was talking to a particular shoe company whose canary deployment is 7,000 nodes. That could be pretty cool. Select all my machines, 7,000 at a time. YOLO. So when I talked about what we're doing in our platform today, you've got the language. It's in the Puppet language. You can use that language today. You can use all these functions today to express ordering. You can use static catalogs once you supply the code ID and code content commands. You can use the examples from the docs to get started if you're using Git. The thing you're missing is the tool that reaches out and runs Puppet in real time and gives you results. That's what we're building. We're adding the API side to the Puppet server, and we're adding a command line client in C++ that you'll be able to use on the Puppet platform. Those are all, of course, already available in Puppet Enterprise. I encourage you to download it and try it if you're not a Puppet Enterprise user today. But in the meantime, I'd like you to use this workflow. And there's a few community tools out there. Ari, the author of MCollective, has written this Choria plugin, which is sort of a next variant of MCollective with some new plugins. It has some new comms. You'll have to do some work to set this up, but I think he would love your feedback on that work. And one of the features of that work is a plugin for running Puppet in order on hosts with respect for ordering and all that. Check that out. There's also another MCollective plugin that Ben Ford of the education team at Puppet has written called Puppet Infrastructure. That gives you a command line client for deploying. You can use MCollective as your transport or SSH as your transport. These are community tools. You may find them not work the way you want. They may not have all the Puppet query language extensions that you're going to get from us. We're going to provide you tooling. I mean these as excellent community options for you to get started today. That's Puppet infrastructure. There's no demo. Thanks, Internet. But I have a few minutes for questions if you have anything to ask, and certainly I hope you enjoyed the conference, and I'll be around for a little longer. In the back. We got one coming for you. Thank you, Sean.
All right, so admittedly dumb question. I talked to some people on the hack sessions on Wednesday. They said the Orchestrator is currently a PE-only thing. So you mentioned Orchestrator with the platform, but that's still Puppet Enterprise. So how do us free open source software goons do this sort of thing?
Oh, sorry, I didn't make that more clear. The Choria plugin and the Puppet infrastructure plugin are how you would do that today. There's a lot of other stuff, and you could go out of band and run Puppet today with just standard M collective after you've done code cache catalogs and static catalogs, and you'll get pretty close. The tooling we're going to add is an API that is consistent with the commercial Orchestrator API. We're going to add that to the Puppet server with a revised communications fabric, and we're going to provide a command line client that is very, very similar to the enterprise command line client for doing this in the platform. It's coming soon. My team's working on it next. It's just we had a lot to do and reorder things, and I'm sorry about that. I wanted to do it sooner. I wanted to have it available for PuppetConf. But the TLDR there is that you're going to have it, and what my entire intent here is that if you're a Puppet platform user today, you can use this workflow. I want you to use this workflow, especially direct change with the Puppet query language. Enjoy that. Get great use from that. And then eventually, I hope you choose Puppet Enterprise. You pay us some money to continue developing great software. When you do that, you're going to get the same experience from the API and the command line client. You'll just have more capabilities that are oriented for teams in the enterprise. Thank you for the question. There's one over with Ari, or there's one there. Thank you.
Can you speak about tagged runs, like if I want to use version tags, and also can you speak to ENC integration or NC integrations?
Okay, thank you. So tags I would like to do soon. We almost did it and just had other priorities, but I'd like you to be able for any job to say, I'd like all of these nodes to apply a specific tag. That should be pretty simple to do. One of the weird things about that we have to solve first is that when you specify tags, the cached catalog doesn't then respect those tags. And so if your intent is to say, enforce this catalog with these tags, and then anytime it wakes up, also enforce those tags, we won't do that. And so we didn't implement it because it's a little bit confusing. And if you didn't know that, you could accidentally reinforce stuff 30 minutes later. So we're going to work on that. I'd like to do it. When it comes to the NC, we're going to provide a way to declare application instances in the node classifier. We just have to do it. It's coming. Thank you.
Thank you for the Choria shout-out. I really appreciate that. Just wanted to mention that on Choria for the open source version of the Orchestrator, I do intend to have fairly close matching, or at least feature ability towards what you saw demo today. I added PQL to Choria and to mCollective Core this week.
Awesome.
So you can do those queries against there and use it for discovery. And I would love feedback on what more you would want from that. The main difference, I believe, and correct me if I'm wrong, the open source coding for Puppet Job won't have any RBAC or anything like that. And mCollective does have an RBAC system, and it may get you a little bit further than if that's what you need, but you're not quite ready to pay for enterprise or whatever. Yeah.
That's right. Thank you for that. I'm excited to see Puppet query language in there. Any other questions? OK, thanks for your time, and enjoy the rest of the conference. I'll take a question now.